Yeah, hi. Today we'll see regarding the Teradata. Teradata now it's buzzing everywhere, and everyone is now migrating nowadays to Teradata. So, what's behind in Teradata? What's the speciality in Teradata when we compare it with respect to the traditional databases? Why it is specifically recommended for data warehousing databases? And if you see now, all the prominent clients like eBay, PayPal, Walmart are nowadays migrate or already on Teradata. If you see whatever the client we just spoke are all the clients which are having their data in petabytes. Okay. If you see in terms of the data arrangement, you're seeing the bytes, megabytes, gigabytes, right? Earlier when we are in startup, we used to use the hard disk of around 50 GB or 100 GB is the max. Now everyone is going for a hard disk. If you see in terms of your dumb systems itself, everyone is running behind saying that I need a 500 GB hard disk. Now there are recent laptops which are coming up with 1 terabyte hard disk. Now if you see the simple spreadsheet packages or the Word documents, it will need a updated RAM itself. In terms of the processing speed, or if you are looking in terms of the volumes of the data that you are filtering up is pretty much increasing, right? See, if you are going for a small shopping mall, they are announcing the discounts. So how and on what basis they are coming up and announcing these discounts? Or if you see everywhere, everyone is coming up with offers. How they're coming up with offers? See, they need to have some data in order to come up with these type of decisions, right? So whatever be the advertisement or whatever be the business scenarios that now are coming need to have a base. So on what basis they will announce, or how they are saying that today, okay, this is on this much cost, and they are predicting it at some point of time this will be on this. If you go for the stock market, if you are picking up a particular stock, everyone will say that this particular earning per this share is this much, and this might be predicted on this much. If you are seeing the quarter results, the company will come up with a growth forecast. How they are analyzing this forecast. This particular YOY, the return will be on this. If you are seeing on a quarterly basis, the demand in this particular quarter is very high, but my second quarter result will be pretty much less. On a year on year, my result will be going to be at an increase of 30% rather than previous year's earnings. How they are forecasting these results? There needs to be some data. How they are predicting that? Because they are having a relied information which is there in the system. Okay, so for anything, everyone will ask on what point you are saying, or on what point you are projecting your forecast. So in order to have a forecast, I need to rely on my system. I need to rely on the data which is there in my system. I can't rely on the current month's data in order to come up with my forecast. Let's say my business is running in good progress in this month. I can't assure the same in the next month. Or my business will be good in this current quarter. I can't say that it will be the same in my next quarter. Let's say I earn $100 million in this month. I can't expect, it might be $150 million or It might be $70 also. I can't project it on the simple current month data. If let's say in the past quarter or in the last month, my sale was $75 million and in the current month it is $100 million. I can't expect it to be a $125 million on basing on the data which I had in the last month and whatever the sales I had and whatever the revenue that I have in the current month. In order to give out a forecast for the next month or the next quarter or the next year, which will be future guidance to my business, I shouldn't rely on the current data or in the past data. I will rely on the past few quarters to the past few years of the data, right? Then only I can able to identify the trend in my business. Okay, this particular quarter I have damn good of my business and this is the off-peak time for my business. And the next 2 quarters I'm going to do again a good business. Third quarter it will be average and again the fourth quarter my business will be damn good. Which will be again an entry criteria for my first quarter in the next year. Like that I'll be identifying my trends in my business based on the past experience I have. This past experience is identified by the trends in my data which I have it in my data warehouse, right? All the data that is spread across the years, I will not store them in my current transaction system. What is this transaction system? An ATM machine where you are going and withdrawing your money is a transaction system. A shop where you are going and purchasing some goods is your transaction system. This particular shop might be spread across different locations. Whatever be the ATM you are going, the same bank ATM will be spread across many different areas, right? So all where you are getting service are called transaction processing systems. So these transaction processing systems where you are going and getting the service within a short span of time, which might be from seconds to minutes, right? Then only you will call it as a transaction, right? Suppose you are inserting your card into your ATM machine and you will not wait for 1 hour or 2 hours to get your money, right? You will be inserting the card, you will be getting your money in a 2 to 3 seconds of span, right? That is the span of the transaction, right? So it will be having the transaction time will be very much less. These are called as the transaction systems, okay? So all these service centers will hold the transactional data, right? Suppose you went to your shopping center and you have bought some goods, like many customers will get the service from the shop on that particular day. So if you see, if the days pass on, there will be huge volumes of the data in your system. If you are still maintaining the same data in your transactional system, you will be facing a space crunch, right? And when you are trying to retrieve any data from this huge volume of the record, which along from the service point, it will be a tedious task, right? So we will be archiving the data from the transactional systems and we will be moving that data into your separate place where you will be placing all your old transactions data into a place. The place where you are keeping all these old transactions data is called as a data warehouse, right? So whatever be the data, after these many days you will be moving it to your data warehouse. From data warehouse, you want to find out, or from the data you are having in your data warehouse, you want to find out the sales pattern of particular good from past few quarters. So you will be analyzing millions of records, and from that millions of records, with analyzing this particular millions of records, you are pulling out a decision, or you are pulling out some data with respect to a particular company's product, how it is going on, how it is moving. I want to identify, let's say I want to identify the movement of the Blumen string, or let's say I want to identify the sale of my packages. In this particular quarter, I have 13 million transactions which are holding the data of different brands by different customers. In these particular 30 million transactions, I need to analyze all these 30 million transactions. Is there any purchase with respect to packages in these 30 million transactions? I need to analyze these 30 million transactions. In these 30 million transactions, how many transactions are with respect to packages? I want to identify this, right? So I am analyzing millions of records, and after analyzing these millions of records, I am getting my subset of data, right? I am analyzing millions of records, huge volume of records. So in order to analyze these millions or billions of records, I need a database with good performance or capability, which will process these millions and billions of records in a faster manner. So, with respect to the traditional RDBMS like SQL Server or Oracle, will it be possible? The thing is, why everyone is going for their Teradata database with respect to data warehousing rather than this traditional RDBMS. There are some implementation with respect to SQL Server as well as the Oracle systems, but they are acting as the source systems. But in terms of the data warehouse, everyone is going nowadays for Teradata, because these traditional databases don't have a parallel nature, or they are not having that much performance to analyze these gigabytes and terabytes of the data to process. They are not having that much capability. A Teradata can support up to petabytes of the data. Okay? None of the traditional databases will support petabytes of data in terms of processing. Teradata has its capability in its architecture itself. It's built on a concept called parallelism. Okay? It's built on a capability called parallelism. But every traditional database will say that we support parallelism. If you see the definition itself, Oracle supports parallelism. SQL Server supports parallelism. It's supporting. Okay? They're not inbuilt with parallelism. See, let's take an example. You are going on a 6-liner expressway corridor. Okay? On a 6-liner expressway corridor, 6 vehicles can go side by side on this expressway corridor. Okay? And you are traveling on this road. You are moving ahead in your journey. All 6 vehicles are going with a constant speed. With the same speed. They are going side by side. On the expressway, they encountered a narrow tunnel. which is of a two-liner. So through that tunnel, only two vehicles can go at a time side by side. So these six vehicles which are going side by side on this expressway need to merge into a two-liner and need to pass through this underground tunnel on the expressway, and again after crossing this expressway it is again expanding it into six-liner once again. So if you see the pace of clearing on the road, they are moving with good pace. Again, there is a congestion on the road. There will be congestion happening near the tunnel because it's not allowing all the six vehicles to pass through the tunnel at a time. Right? Here there is a congestion of traffic happening near the tunnel, because the tunnel is not having the capability of allowing all the six vehicles at a time because it's a two-liner. Similar is the case. This is because, as I said, they support parallelism. If you compare the same journey with a Teradata, as I told you, it has been built on parallelism. It will be a journey like a six-liner road, all six vehicles traveling side by side on this express highway. On encountering the tunnel will also have the capability of the six-liner itself. So all six vehicles can pass through the tunnel at a time, and there is no congestion at all. After coming out of the tunnel also, it will be the same express highway. The tunnel itself is accommodating all the vehicles at a time. There is no stoppage at all in the meanwhile. This is because of the parallel thing, and because of the internal architecture things that are there in Teradata. Okay. See, if you are executing a request in an Oracle system with n number, let's say you fired a query like select star from this particular table, XYZ table. Okay. You logged it. This is a pretty much huge table which is of size in gigabytes. Let's say it is of 100 GB. Right? In warehousing environment, you can see the tables of gigabytes to terabytes also. Okay. So when you are accessing this table, if you see it in a physical perspective, in terms of Oracle, the data will be stored on the disk in the form of data files. The hard disk is in the form of slices called data files. So when you are inserting a 40 GB volume of records into the table, first it will insert the record into the first data file. Once this data file is filled up, it will allocate, the system will allocate, and then the DBA will add another set of data files. Once these are consumed, he will allocate another set of data files to the system. Okay, and now my 40 GB of table is on my system. So if I had a request saying that select star from XYZ table, means you are selecting all the records, that million records from your system. So how it will be executed on the Oracle system? So you are specifying that, okay, I want to finish it off in a quicker manner. Say with this attitude, you find the query with n number of sessions. Okay. So when it is retrieving the data and sending it to the user, by means of the requested sessions, it will establish n number of logins to your system by means of the requested number of sessions, and while coming to retrieval of the data from the table, all these sessions will access this single data file 1. After reading all the data from data file 1, all these sessions will again move to data file 2 and vice versa till the, and it will go on till, it will go on till the last data file, right? So all the data sessions that are reading the data are reading from a single data file. That is what we call the narrow tunnel. All the sessions, if you compare them with the express highway, are merging near the tunnel. Similarly, all sessions are accessing the single data file. Here it is, as I told you, it is creating a congestion, right? Here it is narrowing the capability of the parallelism into a single one, serializer thing, right? All parallel sessions are accessing a single data file. Whereas in the case of a Teradata system, it is built with parallelism. Okay? I'll show you in a picture format. It will be the internal in terms of a Teradata architecture. Okay, you will be seeing some components called AMPs and parsing engine. This is the internal structure of the Teradata system. Whatever be the structure you are creating, means if you are creating a table, it will be replicated. When you are creating a table, first it will create the table header, right? The table header will be created on these AMPs. So what are these AMPs? AMPs are called, whatever be the number of AMPs you are having in your system will be the units of parallelism of your system. Okay. As I told you that the Oracle will write the data to the data file. Similarly, AMPs are connected to the disk. If you see the AMPs, each AMP is having a disk. Okay? Each AMP is connected to a disk. And each AMP will hold the portion of the table. How it will hold the portion of the table. And why it is holding the portion of the table. On what basis it is splitting the table into the portions. Okay. See, when a particular request comes, as I told you the example of express highway and tunnel, let's say you logged in with n number of sessions. All these sessions will be logged into or acting upon each of the AMP. Let's say I logged in with 4 sessions. In Oracle, all these 4 sessions will act on a single data file. Means a chunk of the memory, right? Similarly, in terms of Teradata, all the 4 sessions will logged onto the system. In the system, when they are acting on the memory in order to retrieve the data from the table, okay, they will be each session will be accessing each of the AMP in my system. Okay, each session will access each of the AMP in terms of the expressway. Each line allocated to each of the vehicle is a section, and in terms of internally in the tunnel also they are going in their allocated lane. Similarly, each session will be allocating each of the AMP in the system. Okay. So going deeper into the Teradata architecture, so coming into the going into the deeper understanding of the Teradata architecture, if you compare it with the traditional databases, as I told you, it is built on parallelism. Okay. So as I told you, the amps are the number of units of parallelism available in my system. If If you see in this picture, I have a 4 amp system, which will be indicating that my system is having 4 units of parallelism. Means rather than reading from a single file, it is parallelly reading from 4 different places the same date, same table. How we will see now. Okay, so there are some components called as nodes in my system, Teradata system. What is this node? Okay, see, in terms of the physical individual desktop, you will be having your dedicated CPU to your system, right? In terms of CPU, if you see that, it will have a hard disk and RAM and whatever be the components. So your data will be in the hard disk and it will be retrieved by means of your processor as per the processing speed, right? So Teradata system will have some components called node. A node is a bundle of CPUs where it will have some space in order to store the data and some other hardware components in order to access or in order to process the data, like in a system. Okay. So the other hardware components are these AMPs and Ps, and the space is this cylindrical structure, what we are calling it as a disk. Okay. So when we are accessing a Teradata system, when you are establishing your session with the database, and when you are creating a table on your Teradata database, it will replicate the table header on each of the amps. Okay. See, if you see the structure figure, each AMP is having a cylindrical structure which is called as a V-disk, means virtual disk. Okay, virtual disk. Why I am saying it as a virtual disk? It's not a physical disk. Okay, why I am saying it as a virtual disk is, see, if you see your laptop or your desktop hard disk, you will be having a 500 GB hard disk, only a physical single hard disk drive, right? So, but when you are seeing it, your drives configured in your system, when you are looking in your mic, when you open your My Computer, you will be seeing different drives, right? Drive C, drive D, drive E, drive F. Drive C is holding 150 GB, drive D is holding 150 GB, drive E is holding 150 GB, and drive F is holding 50 GB of space. These are logically partitioned on your hard disk, but physically they are on the same hard disk, right? Whatever be the partitions, space allocating for your drive C or drive D or E or F, these are the logical partitions, right? Similarly, the hard disk will be the same, but a portion of the space is allocated to these AMPs. So whatever be the space allocated or reserved for AMP1 will not be allowed to use by the rest of the AMPs in your system. Okay, that's why Teradata system is called as a shared nothing architecture. Okay, it's called as a shared nothing architecture. And what about these AMPs? Why these AMPs are allocated with the set of the hard disk? And what are the things done by these AMPs? How they will act upon the request? From where these AMPs will get the request? Need to be known, right? So these AMPs are not the standalone things. They cannot work on their own. They cannot think on their own. See, in a project, a team member will not get a project by himself and he will not segregate the work by himself, right? He will be dictated by his boss. Either it can be a team lead or it can be a project lead, right? Similarly, these amps will have a boss called as a parsing engine. This parsing engine, based on the request sent by the client or based on the request sent by an individual, whatever be the request, database request, it is requesting, it will analyze the request. Okay, this particular user has tried a query like select star from this XYZ table where salary equal to this much. So it is restricting the data, or let's say he has fired a raw query like select star from this table XYZ. Okay. So how to process this request? How can I retrieve the data in a faster manner? See, retrieving the data can be done by any database, traditional databases, right? But how to retrieve the data in a faster manner? That's where the factor is. If I am doing a thing in a short span of time, everyone will come up to me saying that okay, please go ahead with this task. If two persons are working on a same task, if one person is able to do it in 5 minutes and other person is taking 50 minutes, whenever a person comes, whenever a new task has to be assigned, it will be assigned for the person who is working in a short span of time, right? Because he is performing more. It's proven thing, right? Similarly, in terms of retrieving of the database, it can be done by any of the RDBMS available in the market. But being parallel in nature as a Teradata database, okay, it needs to be done in a faster manner, right? Then only we can say it as a parallel database, and then only you can go for parallel the Teradata database, right? So the data or the request need to be served in a faster manner, right? So whatever be the query you are getting will be optimized, means there will be some analysis done by this team how to serve this request, in how many ways I can serve this request, and what are the different ways in order to serve this request. In these number of options, which will be the best option with less burden on the system and with faster retrieval time. Whatever the best option will be available in the set of options will be picked out by this parsing engine. Okay. This best option will be framed in the form of instruction set, and that instructions are passed to these AMPs. So whenever we are passing a communication or passing instructions to anyone, there should be some sort of medium as a transportation mechanism, right? When you are allocating to a work to your peer or to your team member, it will be done in the form of emails, which is a communication medium between you and your team member, or you and your peer, or between your offshore or onshore, right? Here there is a communication medium that will be sending the instructions from the parsing engine to the AMPs. That communication medium is called as a message passing layer. We can call it as a BiNet. This is called as BiNet in Teradata. This BiNet is the message passing layer that will be used for a communication between an AMP and AMP. Means one AMP in the system to other AMP in the system, or while sending the request from PE or instruction from PE to the AMP, or sending out the response from AMP to the PEs. All these will occur through the message parsing layer, means through the binary. Okay. So when I fire this particular statement, select star from employee table, that data need to be retrieved from these AMPs. So what is the difference it is making between traditional databases and Teradata? As I told you, there is a difference between the traditional database and Teradata within the architecture. So whatever be the records you are inserting in the traditional database, they will be going in a sequential manner. But in terms of Teradata, the data itself is arranged or equally distributed across the AMPs in your system. Let's say I am inserting 1000 records into my system and I am having 4 amps in my system. All these 1000 records are equally distributed across these 4 AMPs. Means a portion of the volume of the record is allocated to each of the amp in my system. Okay. So it is allocated to each of the amp in my subset of records are going for each of the amps. So can we think like, okay, first 250 records to amp 1, next is 250 records to amp 2, and finally the last 250 records to amp 4? Without any logic behind that? Means there is a logic of, there is a there is a algorithm behind this, which is used in Teradata called as row hashing algorithm. This is the algorithm that directs the incoming records into the Teradata system to the designated amps in the system. Okay, this particular record with the record number 1 should go to amp 1. This record with record number 2 should not go to amp 2 or 3 or 1. It should go to amp 4. This will be directed by means of row hashing algorithm. Okay, we are saying that row hashing algorithm is the base. It is using row hashing algorithm in identifying the designated amp where the particular incoming record should go instead. So for an algorithm, we need to have an input. If you are giving out an input, then only the algorithm will direct you the output. So what is the input for this algorithm? We are saying that record number is the input. So will it take whatever be the value in any of the column in the record? If it is taking, it will not be going out, or the output will not be as expected, right? See, you are expecting addition of 2 numbers. You are giving input as 2 and 3, which should be a 5, right? But you are giving the input value for variable 1 as 2, and when you are giving the second value, you are giving some junk value. Let's say you are giving A. What should be the value? It's a junk value, right? You are not getting the proper output. Whatever be the output you are getting is a junk, right? So there is a column which will be considered as an input for this row hashing algorithm. That column is the column that has been defined as a primary indexed column in the table. What is this primary index? A primary index is the main driving factor in Teradata, which distributes the records across the AMPs in your system. which equally distributes the records across your AMPs in your system based on the uniqueness of the values in that particular column. More is the uniqueness, more is the uniform distribution of the data across your AMPs in your system. Okay, based on the primary index column values, which will be fed into the hashing algorithm, based on the hash value or output of the hashing algorithm, that based on that output given by the hashing algorithm, it will find out the designated AMP based on the row hash value which has been came out from row hash value hashing algorithm. It will identify the designated AMP and it will insert the data onto this designated AMP. Okay. So if you see in the picture, there are some records on each and every AMP. Likewise, the data in the table will be a subset of the data of a table will be held or stored on each of every AMP in our system. So when I am saying that select star from table XYZ, what the Teradata system will do is, it will establish a session to each of every AMP in the system. All the sessions will be logged on to the AMP at once. And at a time, it is each of the session is working on each of the AMP and they are retrieving the data from each of the AMP, right? So they are working in parallel on each of the AMP. Let's say you are building a wall. 4 people are working in parallel. Okay, so let's say in order to retrieve 100 records, it is taking 10 seconds. Okay, here there are 1000 records equally spread across all the 4 AMPs. Means each AMP is getting 250 records as its chunk, right? So there are 250 records stored on each of the AMP. In case of traditional RDBMS, when you are retrieving the data which is of these 1000 records, as it is taking 10 seconds for 100 records, it will be 100 seconds in order to retrieve those 1000 records, right? Here, whereas in case of Teradata, as the table is equally distributed or the records are equally distributed across the AMPs and you are logging on to the AMPs at one shot in parallel. So you are working on all the AMPs in parallel and you are retrieving all the 250 records from each of the AMPs in parallel. So you are working on 4 of the AMPs at one shot and you are pulling 250 records from each of them and you are pulling all 1000 records at one shot. So it will be done in 1/4 of the time, right? 2.5 seconds or 2 is the time, right? So you are almost doing the work in 1/4 of the time when you compare it with the other traditional RDBMS, right? Because here you are working on parallel. You are not getting serialized in any of the area while retrieving the data, right? You are establishing n number of sessions, you are logging onto the n number of AMPs and you are retrieving the data by means of n number of sessions and you are delivering the output to the by means of n number of sessions, right? So you are not getting serialized in anywhere like in case of traditional RDBMS, right? So in terms of space also, whatever be the space you are allocating to each of the AMP will be equally distributed across the AMPs. It's not like in the case of our drives which we configure in our laptop like 120, 120, 120 and 40. Whatever the space that will be there, that is there on the system will be equally distributed across the AMPs. Let's say you are having 100 GB hard disk, physical disk. So whatever be the B disk capacity held by each of the AMP will be 25 GB. Means 100 GB by number of AMPs. So that will be the space held by each of the AMP, and whatever be the 25 GB or whatever be the amount of space allocated to AMP1 will not be shared by AMP2, or whatever be the records that are stored in AMP1 space will not be shared by the other AMPs in the system. Whether it can be a system resources like in terms of space, or whether it can be the data stored on the AMP will not be shared by the rest of the AMPs in the system. That's why it is called as a shared nothing architecture. Okay. So in terms of allocation or in terms of distribution of the records, in terms of distributing of the system resources also, it will apply the parallelism in the system. Okay. If you see in terms of the traditional utilities, traditional databases and traditional utilities which we will be using in terms of other databases for loading of the data. Okay. In terms of loading of the data also we are having a n number of utilities in terms of Teradata, whether it be a development perspective or it can be a DBA perspective. In terms of the DBA perspective, when you are loading millions and millions of records, you need to be in touch with your DBA. Because in order to ensure that your job should not end up failing, saying that there is no space on the database, right? So you need to run behind your DBA saying that in order to allocate some space to your job. So your DBA might need to sit before the system and need to monitor how your job is going on, whether it is running out of space. If it is running out of space, you need to add space before the job gets exhausted with the space. Here there is no such concept. The DBA work is a segregated environment. If you see the alerts with respect to space alerts in Teradata system are pretty much, because it's a well-defined system, and if you are loading in terms of the data also, you are having n number of utilities depending upon your project landscape and depending upon your strategy of the loading, depending upon the type of the table. If you see in terms of database and data warehouse environment, you will be coming across different terminologies like staging table, work table, intermediate table, like that. If you are looking in terms of these different types of table, Teradata is having different utilities in order to load different kinds of tables. Okay, whether it is a empty load or it can be a table with the data. And while loading the data itself, you need to look into n number of parameters. Like, I don't want to delete my existing data and I want to load the new data, means the delta, what we will be calling as a delta, right? The incremental load which is coming to the system. I need to load this data. In this loading also I have some updates and some inserts happening on the table. So we'll have different types of utilities based on the type of loading. While loading of the data, I need to have my table availability, or I don't, even if the table is getting loaded, I want my table to be available for the user. It depends on the volume of the data and loading strategy, as I told. Okay. Depending on your loading strategy, you will have different, you can use different utilities. And some projects, they'll use different ETL tools along with the Teradata. So what these ETL tools will do, they'll be doing the extraction of the data, right? See, in terms of extracting the data means, you will be extracting the data from a source system and you will be getting the data in the form of a flat file and you will be loading into your Teradata system by means of applying some transformation logic, right? Similarly, when you are getting if you are seeing it in a Teradata perspective, when you are receiving a flat file, when you are loading it into a target Teradata warehouse, in spite of going for a ETL and spending on some extra license, you can do the extra transformation logic and you can load it on the fly to your Teradata warehouse. You can do the transformation logic also using these Teradata utilities. And when you are loading from a other database, which let's say your other system is in Oracle and you want to load it into Teradata, there is a utility called Teradata Parallel Transporter where you can configure your ODBC connection and you can read your data from Oracle system and you can load it into your Teradata system on the fly, and on the fly itself you can apply your transformation logic and you can load your data into your system. Okay, so Teradata has these vast number of utilities and many number of utilities, not only in terms of the developer perspective of pulling the data or loading or transformation, applying the transformation logic. In terms of the DBA perspective also, it has a well-defined, predefined environment. See, whenever there is a requirement, let's say you have executed a query in the past and it has ran twice on that particular day, and today it's creating a problem. And you want a snapshot of that query, how it has executed on that particular point of time. You can rewind your data. There is a concept of data rewind in Teradata where you can see the execution snapshot, means the explain plan of the query by rewinding your data. You can traverse back how that particular query has been executed in the past, where if you are having that snapshot of that particular query when it has run. Okay, so these are the extra features that are available. If you see the work of a traditional RDBMS DBA with a Teradata DBA, the set of tasks that are there with a Teradata DBA are pretty much less, and the environment is well defined. You can monitor your system by means of a tool called Viewpoint, and you can easily move the space from one database to other database. You can monitor the database growth as well as your table growth in an easy manner. There are that many tools available under Teradata Pack. Okay, you can easily grant, everything is in terms of UI basis, and you can easily monitor your system also. As I told you that there is a capability of going for the rewinding also. And if you see in terms of backups, if you see that backup of a Teradata system itself, it has a specifically designed set of tools called net backup or net vault backups. These are especially designed for tools especially designed for holding or backing up large volumes of the data which is there in terabytes. Okay, so this is regarding the Teradata system. And in terms of a DBA and a developer, we are having n number of utilities which we can discuss in further sessions. Okay, thank you.